German planners expected weeks of chaos after Allied bombings. Instead, they watched shattered railways come back to life, sometimes before the dust had even settled. In the spring of 1944, German planners believed they understood the invasion problem. They had no doubt the Allies would land somewhere in France. They had no doubt about the size of the assault. What they believed, quietly with confidence, was that it could be contained. Not by tanks, not by counterattacks, but by logistics. For decades, France's railway network had been among the most integrated in Europe. It supplied cities, factories, ports, and armies with mechanical precision. And to German engineers, that system had one critical weakness. It could be broken. Railways, unlike roads, were brittle. Destroy the bridges, smash the switching yards, crater the track beds. An army could move on foot for a time, but it could not survive without trains. This belief hardened into doctrine. By late 1943, German logistics staff had mapped every major rail hub in northern France. They listed bridges by span length. They ranked marshalling yards by throughput. They calculated how many days, often weeks, it would take to rebuild each target after destruction. The figures were reassuring. A steel bridge blown over a river? At least 10 days to regain load-bearing strength. A switching yard reduced to rubble? 2 to 3 weeks before traffic normalized. A rail junction cratered by heavy bombing? Possibly a month. German engineers were not speculating. They were experienced. They had rebuilt railways across Eastern Europe under harsh conditions. They understood steel. They understood concrete. They understood how long proper work required. And that understanding shaped everything that followed. When Allied bombers intensified attacks on French rail infrastructure in early 1944, German reports remained almost calm. Bridges destroyed, lines severed, yards burned. The expectation was not panic. It was delay. Delay meant time. Time meant reserves could move. Time meant coastal defenses could regroup. Time meant the invasion force would slow, stretch, and eventually stall. Railways, German officers believed, were not something you could improvise. They were systems, complex, fragile, slow to recover. That assumption ran so deep that it endured even after D-Day itself. When Allied troops landed in Normandy, German planners did not immediately assume disaster. They assumed friction. Beaches could be supplied by trucks temporarily, but trucks consumed fuel. They damaged roads. They broke down. Without railways, the Allied advance would choke itself. That was the theory. Inside German staff rooms, the logic felt airtight. Rail repair required specialized crews. It required heavy machinery. It required time to survey damage, pour foundations, align track beds, and test loads. Even if the Allies attempted repairs, German bombers could strike again. Repeated destruction would compound delays. The railways would become graveyards of half-finished work. At least, that was the expectation. What German engineers underestimated was not American industry. They knew the United States could produce steel. They knew it could build locomotives. What they underestimated was something subtler: the American willingness to accept imperfection. German engineering culture emphasized permanence. A bridge was rebuilt to last. A rail line was restored to specification. Temporary solutions were viewed with suspicion. They failed inspections. They invited collapse. American doctrine did not treat railways as monuments. They treated them as tools. If a bridge could carry a train today, it was sufficient. Tomorrow could wait. This difference in mindset would prove decisive. But in early June 1944, German planners did not yet see it. Their maps still showed black gaps where rail lines had been destroyed. Their reports still predicted weeks of disruption. Their assumptions remained intact. The Allies, they believed, were about to encounter the limits of momentum. The invasion would slow. Supplies would bottleneck. The war would grind back toward balance. They were wrong. Within days, sometimes hours, the evidence appeared. Reconnaissance photos showed tracks returning where none should have existed. Trains were spotted moving through zones still labeled non-operational. At first, German analysts dismissed the sightings. A single train did not mean capacity. Temporary movement did not mean sustainability. But the reports continued. And gradually, an unsettling question took shape. What if the railways were not staying broken? That question would haunt German planners for the rest of the campaign in France. Because the assumption anchoring their strategy, that destroying railways guaranteed paralysis, was already collapsing. They simply did not know it yet. Welcome to WWII Forgotten Fronts, a channel dedicated to the untold battles, the overlooked heroes, and the hidden machines that shaped the Second World War. Here we dive beyond the famous headlines to uncover stories buried in diaries, lost archives, and forgotten front lines. If you're passionate about deep storytelling, real wartime experiences, and cinematic history, you've just found your new home. Make sure to subscribe, leave a like, and share this video. Your support helps this channel continue bringing these forgotten chapters of history back to life. Now, let's step into the past. The destruction of France's railways was no accident. It was deliberate, measured, systematic. By early 1944, Allied air commanders had reached a conclusion that reshaped the invasion to come. If German armies were to be defeated in France, their logistics had to be crippled before a single soldier set foot ashore. Railways became the priority. Allied planners examined France the way surgeons study anatomy. Every junction traced. Every marshalling yard photographed. Every bridge measured, classified, and ranked. Not all rail hubs were equal. Some fed entire regions. Others served only local traffic. The objective was never random destruction. It was selective paralysis. Beginning in the spring of 1944, bombers struck rail infrastructure with increasing intensity. Switching yards flattened, bridges broken apart mid-span. Rails twisted into useless coils. Entire networks went dark. From the air, the damage looked total. From the German perspective, it appeared to be working exactly as expected. Reports from occupied France described confusion and disruption. Freight trains stranded between junctions. Locomotives abandoned with empty tenders. Yards choked with wreckage too heavy to clear quickly. German railway engineers sent urgent assessments up the chain of command. Their conclusions aligned. The damage was severe. Repairs would take time. German doctrine treated rail repair as a disciplined process. First came inspection, careful surveys of load-bearing structures, then clearance, manual removal of debris to avoid destabilizing foundations. Only afterward could rebuilding begin. Steel bridges demanded precision. Track alignment required exact tolerances. Any shortcut risked derailment under load. And derailments were unacceptable. One failure could shut down an entire line. From the German view, caution was not delay. It was responsibility. This mindset reinforced German confidence. They did not believe the Allies could bypass the fundamentals of rail engineering. They assumed the Americans faced the same limits. Steel was steel. Physics was physics. Bomb damage could not be undone by enthusiasm. As D-Day approached, German planners grew almost reassured by the condition of France's railways. Maps showed widespread disruption. Rail traffic figures collapsed. Throughput dropped sharply in key regions. The expectation was that once Allied troops landed, they would rely on trucks and improvised routes. Those would suffice for a time. But without railways, any major inland advance would slow dramatically. That belief became a quiet source of confidence. In some staff assessments, rail destruction was called the invisible second front. The beaches might fall. The countryside might be contested, but the railways would decide the campaign. Even after June 6, 1944, this confidence endured. German units near the front reported Allied movement. They observed growing troop concentrations, but they also noted constraints, fuel shortages, traffic congestion, overburdened roads. From a logistics perspective, these looked like early signs of success. The Allies were straining their own systems. What German planners did not yet grasp was that they were measuring the wrong standard. They tracked permanent capacity. The Allies exploited temporary sufficiency. A rail line did not need full restoration to matter. It only had to function enough to move supplies forward. One train was not a system, but it was momentum. The bombing campaign had succeeded, just not in the way Germany expected. Yes, bridges were destroyed. Yes, yards were shattered. But destruction alone did not equal denial. Not if repairs could outrun attacks. The first real warnings emerged from reconnaissance analysis. Photographs taken days apart revealed changes that should not have existed. Temporary spans appeared where rivers had been crossed only by rubble. Tracks returned where craters had dominated the ground. Most troubling of all, trains began to move. German analysts initially dismissed the sightings. A single locomotive could be deception. Captured equipment, a local anomaly. But the reports multiplied, and they followed a pattern. The same locations that had been bombed were coming back online, not perfectly, not permanently, but rapidly. This contradicted everything German engineers believed about rail reconstruction. There were no signs of long-term rebuilding, no extensive foundation work, no careful re-engineering. Instead, the repairs looked crude, industrial, improvised. And yet, they functioned. At first, German planners assumed this success would be brief. They expected failures, collapses, derailments under heavy loads. They trusted physics to assert itself. It always had. But the failures did not come. Days passed. Supply flows increased. The bombing campaign had destroyed the railways, but it had not destroyed the Allies' ability to use them. And slowly, an unsettling realization took shape. The Americans were not rebuilding France's railways. They were bypassing German assumptions about how railways had to be rebuilt at all. The bombing campaign, once seen as a decisive chokehold, was becoming something else, a race, and Germany was beginning to lose it. The first signs that something was wrong did not come from combat reports. They came from photographs. German reconnaissance aircraft flew the same routes they had flown for months, recording bomb damage across occupied France. Their task was routine: confirm destruction, track repairs, estimate downtime. What appeared in the images did not match expectations. In several areas west of Paris and behind the Normandy front, bridges listed as non-repairable in the short term were no longer empty gaps. They were crossings again. Not permanent bridges, not rebuilt monuments of steel and concrete, but structures that carried trains. At first, analysts suspected error. Perhaps the photographs were misdated. Perhaps the angles were deceptive. Perhaps the spans were lighter than they looked. Rail engineers insisted the original assessments were correct. The damage had been catastrophic. Proper repairs should have taken weeks. The images suggested days. German staff officers asked a simple question: what exactly are we seeing? The answer disturbed them. These were not rebuilt bridges in the German sense. They were functional bridges, assembled rapidly, often laid directly over rubble, built not for durability but for immediate use. They violated every engineering principle German specialists were trained to respect. And yet, they functioned. The first confirmed train moving through a recently bombed sector triggered urgent reporting. Rail officials cross-checked schedules. They confirmed locomotive sightings. They questioned local commanders. The conclusion was unavoidable. Allied trains were running on lines that should have been dead. This was not supposed to happen. Railways were meant to be brittle. Their complexity was meant to prevent rapid repair. That was the theory. The Americans treated complexity as a nuisance. In one instance, a rail bridge destroyed by heavy bombing was reported operational within 48 hours. German engineers had estimated at least 10 days, assuming uninterrupted work and full material access. Instead of rebuilding from the foundations, Allied engineers erected a temporary steel span using prefabricated components brought forward behind the front. No concrete curing, no precise alignment. The bridge flexed slightly under load. The trains crossed anyway. German officers struggled to interpret this. Technically, the structures were inadequate. They would never pass German inspection standards. They were vulnerable to renewed attack. But inspections did not matter if the bridge existed only long enough to move supplies. This distinction had not yet fully sunk in. Worse, there was a pattern. These were not isolated cases. They appeared simultaneously across multiple sectors. Where one line was destroyed, another reappeared nearby. Where a bridge was bombed, traffic shifted to a temporary crossing. The rail network was no longer fixed. It was adaptive. German planners began to understand that their bombing campaign was achieving destruction, but not denial. They could destroy the same target repeatedly, but each strike forced faster Allied response, not delay. Repairs grew more aggressive. Methods simpler, timelines shorter. The Allies were learning as they went. The shock was not only technical, it was psychological. German doctrine assumed rail repair was inherently slow. That belief had shaped planning, occupation policy, and defensive strategy. Now it was unraveling. One German report stated bluntly, "The enemy does not rebuild railways, he replaces them." The distinction mattered. Rebuilding implied permanence. Replacement meant speed. As German engineers tried to forecast Allied movements, their models failed. Timetables became unreliable. Capacity estimates collapsed. A line unusable on paper might carry traffic for days before being destroyed again, only to reappear elsewhere. The system had become fluid. Attempts were made to respond. German bombers increased attacks on repair sites. Sabotage teams targeted temporary bridges. But the Allies adapted. Repairs were carried out at night. Bridges were camouflaged. Routes changed constantly. Destroying one span no longer ensured interruption. It only forced relocation. The realization spread steadily through German command. They were no longer fighting an enemy bound by traditional engineering limits. They were facing an enemy willing to trade elegance for momentum. For engineers trained to value precision and permanence, this was deeply unsettling. Everything they knew said these methods should fail. But failure did not come quickly enough. France's railways were not returning to their pre-war form. They were becoming something entirely different. A temporary, modular, constantly shifting system built for one purpose alone, to keep Allied armies moving. This was the first real shock. Not the landings, not the fighting, but the realization that the logistical assumptions behind Germany's defense in France were wrong. Fundamentally wrong. And behind every repaired line, every improvised bridge, every moving train, stood a force German planners had barely accounted for. Specialized American railway units whose doctrine centered on speed. The next question was unavoidable. Who were these engineers, and how were they doing it? German planners had built their thinking around bridges, rails, and steel. They had not built it around people. That was the first error. The rail repairs that stunned German engineers were not carried out by improvised labor or local contractors forced into service. They were performed by specialized U.S. Army railway battalions, units formed years before the invasion and trained for a single mission, to restore rail movement under combat conditions as quickly as possible. These were not standard engineer units. They were not traditional construction troops. They were logistics weapons. Each railway battalion was a mixed organization. It brought together civil engineers, heavy equipment operators, steel workers, crane crews, and locomotive specialists under one command. Many of the soldiers had worked on American railroads before the war. They understood track geometry, load limits, and rolling stock as everyday practice, not abstract theory. What set them apart was not expertise. It was doctrine. German rail engineers were trained to rebuild railways as complete systems. American railway battalions were trained to restore movement. That difference was critical. Movement could be limited. Movement could be temporary. Movement could be crude. If trains moved, the mission was achieved. Before D-Day, these units trained continuously in Britain. They practiced assembling bridges from prefabricated sections. They drilled night repairs under blackout conditions. They rehearsed clearing wreckage with bulldozers instead of manual labor. Speed was not optional. It was required. American planners understood something German doctrine did not fully accept. Railways did not need perfection to be decisive. They needed availability. A line that carried 10 trains a day for 3 days could matter more than a flawless line restored weeks later. That logic shaped everything. When Allied forces landed in France, railway battalions moved in close behind. They did not wait for stabilized front lines. They did not wait for complete air superiority. They entered shattered rail zones while bombs were still falling. Their schedules were measured in hours. A destroyed bridge triggered a standardized response, survey to assess damage within minutes, not days. If foundations remained, prefabricated spans were rushed forward at once. If foundations were gone, temporary trestles were built directly on rubble. German engineers would have rejected such work immediately. American battalions accepted the risk. Prefabrication made this possible. Instead of custom construction on site, American engineers relied on modular steel components designed for rapid assembly. They could be moved by truck. They could be lifted by crane. They required minimal preparation. Once installed, they were strong enough to carry loaded trains. If not forever, then long enough. Long enough was sufficient. German air attacks did not halt the process. They accelerated it. Railway battalions repaired at night and dispersed during the day. They camouflaged bridges. They built alternate routes nearby. If one span was destroyed, another appeared elsewhere. The rail network became unpredictable. German planners struggled to strike what could not be fixed in place. There was no single bridge to destroy permanently. No junction whose loss guaranteed paralysis. Everything was temporary. Everything was replaceable. The battalions also embraced machinery. Bulldozers replaced hand crews. Portable cranes lifted rail sections directly into position. Damaged track beds were bypassed rather than rebuilt. German repair doctrine valued craftsmanship. American doctrine valued throughput. This difference went beyond engineering. German officers believed shortcuts created weakness. American officers believed delay meant defeat. In a war driven by momentum, speed meant survival. The railway battalions did not see themselves as builders. They saw themselves as enablers. Their mission was not to restore France's railways. It was to keep Allied armies supplied long enough to win. Everything else was secondary. This mindset baffled German engineers. From their perspective, the Americans violated every rule of proper rail construction. Yet trains kept moving, supplies kept flowing, the front kept advancing. When German commanders demanded answers, their engineers could offer only one. The Americans were fighting a different war. Germany was still fighting a war of infrastructure. The Allies were fighting a war of systems and tempo. The railway battalions embodied that difference. They were not celebrated units. They rarely appeared in propaganda. But behind every advance, behind every fueled tank and supplied infantry unit, their work was there. Unseen, crude, decisive. German planners had expected Allied logistics to collapse under destruction. Instead, they faced an enemy whose logistics adapted faster than they could be destroyed, and the railway battalions stood at the center of that realization. Speed alone could not account for what German planners were witnessing. Men could work faster, crews could be driven harder, but speed on this scale demanded something more. It demanded machines. German railway doctrine still depended heavily on manpower. Clearing wreckage was done by hand. Steel was cut, sorted, and lifted carefully. Precision came first, even when time was scarce. American railway battalions chose a different path. They replaced labor with horsepower. Bulldozers were the first shock. Where German engineers organized crews to dismantle twisted steel piece by piece, American units simply pushed it aside. Wrecked locomotives were dragged clear. Collapsed girders were shoved into embankments. Whole fields of debris vanished in hours. The objective was not recovery, it was clearance. To German engineers, this approach looked reckless. Steel had value, machinery could be repaired, debris should be salvaged. The Americans were unconcerned. If the line reopened, the debris no longer mattered. Portable cranes amplified the effect. Instead of building complex lifting frames, railway battalions deployed truck-mounted cranes that could place prefabricated bridge sections directly into position. No permanent foundations, no prolonged alignment. The cranes arrived, lifted, set, and moved on. Each site became a temporary workshop. At the center of this system was prefabrication. American planners had anticipated destruction long before D-Day. They did not intend to rebuild what was lost. They intended to replace it. Bridge components were prefabricated in Britain ahead of time. Standard steel trusses were cut, drilled, and tested before the invasion began. Every piece fit a predictable system. Crews did not design bridges on site. They assembled them. This removed delays caused by calculation, surveying, and debate. German engineers treated bridges as unique answers to unique problems. American engineers treated bridges as interchangeable parts. If a river needed crossing, the solution was not a drawing, it was a crate. The same logic applied to track repair. Instead of restoring track beds to pre-war standards, American battalions often bypassed them entirely. Temporary rails were laid over compacted rubble. Sleepers were aligned only well enough to carry weight. Accuracy was traded for speed, and speed was paramount. From the German engineering viewpoint, this bordered on insanity. Track tolerances existed for safety. Poor alignment caused derailments. The Americans accepted that risk. They compensated by limiting speed and load. A slow train was preferable to no train at all. Machines also reduced exposure. Bulldozers and cranes allowed crews to work quickly and withdraw. Sites were active for hours, not days. German bombers frequently arrived too late. By the time bombs fell, the bridge had already served its purpose. This forced German planners to reconsider targeting. Repeated attacks on the same site no longer ensured disruption. Temporary bridges could be rebuilt faster than aircraft could return. Destroying infrastructure produced diminishing returns. The Americans exploited this dynamic. Railway battalions began constructing multiple alternatives. Rather than repairing a single bridge repeatedly, they built parallel temporary crossings nearby. German reconnaissance struggled to keep track. Maps were outdated almost as soon as they were drawn. Machinery also enabled night work. With artificial lighting and heavy equipment, repairs continued in darkness. German pilots reported bridges appearing overnight. By morning, trains were already moving. The damage had not been erased. It had been outrun. This mechanized method reflected a broader American industrial mindset. Problems were addressed through scale, through redundancy, through speed. If one solution failed, another replaced it. German engineering aimed to prevent failure. American engineering assumed it and planned around it. The outcome was a logistics system that reacted differently under pressure. Bombing deepened disruption in German-controlled networks. Bombing accelerated adaptation in Allied ones. The same pressure produced opposite effects. German engineers watching this unfold reached an uncomfortable conclusion. Their own machinery was scarce. Fuel was limited. Production was strained. American units appeared to have endless equipment, bulldozers, cranes, trucks, each acting as a force multiplier. But machines alone did not decide the outcome. They only made it possible. What mattered was how they were employed. And that was dictated by doctrine. German doctrine emphasized restoration. American doctrine emphasized throughput. German repairs sought completion. American repairs sought continuity. One aimed for a final state. The other pursued momentum. By mid-1944, the contrast was undeniable. Railways meant to be neutralized were supplying Allied armies. Bridges intended as decisive targets had become temporary obstacles. Machinery had turned rail repair from a bottleneck into a moving target. German planners now confronted a harsh reality. They were not fighting Allied troops alone. They were fighting an industrial system optimized for speed under fire. And the machines were only the beginning. The struggle for France's railways did not obey daylight. It followed opportunity. German air doctrine assumed a simple cycle: bomb during the day, repair during the day. Repeat. The Allies broke that cycle. They made the night their workshop. As German bombers hit rail hubs and bridges, American railway battalions waited. Not days, not even hours, sometimes only minutes. Once the last aircraft departed, repair crews moved in. Lights came on, engines roared, steel shifted. By sunrise, the damage had already begun to change form. Night work was not improvised. It was deliberate. Railway battalions trained under blackout conditions long before crossing the channel. They learned to raise bridges by lamplight, lay track by feel, and operate cranes with limited visibility. Darkness did not slow them. It hid them. German pilots frequently reported a disturbing pattern. Targets destroyed the previous evening no longer matched dawn reconnaissance photographs. The craters remained. The wreckage was still visible, but rails now crossed through them. The night war put German air forces at a disadvantage. Bombing accuracy fell sharply after sunset. Temporary bridges were difficult to detect. Repair crews vanished before daylight. Even successful strikes rarely produced lasting effects. The window of disruption was too narrow. American engineers took full advantage. They worked in short cycles. Clear, assemble, move. A bridge did not need to last a week. It only needed to last a night. German commanders responded by ordering repeated attacks. The same bridge, the same junction. But the Americans anticipated this. They built alternates nearby. They shifted routes. They allowed German bombers to destroy yesterday's fix, while today's solution operated elsewhere. The rail network became a shell game. Night repairs altered the psychological balance. German units expected disruption to persist. They expected broken lines to slow Allied advances. Instead, movement resumed with unsettling regularity. Each morning brought the same surprise. Supplies had arrived again. For German frontline commanders, the pattern was infuriating. Air reports confirmed successful strikes. Rail damage was documented. Yet ammunition stocks continued to grow. Fuel shortages failed to appear. The trains kept running. The night war revealed a deeper imbalance. German logistics depended on predictability. American logistics thrived on adaptability. The harder Germany tried to disrupt the system, the faster it adjusted. Railway battalions learned to work quickly and leave no fixed footprint. Equipment was staged away from repair sites. Crews rotated constantly. No location remained active long enough to become a dependable target. Bombing destroyed structures. It did not destroy methods. German intelligence struggled to keep up. By the time a repair site was identified, it was often already abandoned. Maps trailed reality by days. In a campaign measured in hours, that delay was decisive. Night also allowed Americans to accept risks daylight discouraged. Temporary alignments, minimal inspections, restricted speed limits. These choices would have been unacceptable in peacetime. In war, they proved decisive. German engineers anticipated derailments. They waited for catastrophic failures. They happened, occasionally, but the Allies absorbed them. The wreck was cleared. The line reopened. Momentum continued. The Night War erased the clear boundary between destruction and repair. Bombing no longer meant denial. It meant a challenge. And the Americans responded faster than Germany could adapt. By late summer 1944, German pilots understood the futility. Destroying a bridge no longer stopped traffic. It delayed it. And delay was no longer enough. France's railways had become a round-the-clock battlefield. Bombs by night, repairs by night, both sides racing time. Only one side had prepared for that race. German commanders now faced a strategic truth they could not ignore. The railways were not collapsing. They were transforming. And with every night, the Allies grew more adept at turning darkness into advantage. The Night War had altered the balance, and Germany was losing it. The real effect of the rail repairs was not counted in bridges rebuilt or kilometers of track restored. It was felt at the front. German commanders expected the Allied advance to bog down after Normandy. They believed the beaches would become bottlenecks, that trucks would choke the roads, that fuel and ammunition would arrive sporadically, if at all. Instead, the opposite occurred. Within weeks of D-Day, Allied frontline units reported something rare in a major offensive: reliable supply. Fuel arrived on schedule. Ammunition stocks stayed stable. Replacements and equipment followed predictable timetables. Shortages existed, but they were brief. They did not dictate operations. German officers searching for answers kept returning to the same explanation. The railways were sustaining the front. This was not how the campaign was meant to develop. An army of that size, operating without intact rail infrastructure, should have struggled to maintain momentum. But the Allies did not depend on railways in the traditional way. They used them as force multipliers. Trucks still moved supplies inland from the beaches. But railways took over as soon as they could. Every kilometer of track restored shortened truck routes. Every temporary bridge reduced strain on roads. The effect accumulated. German planners had assumed rail repair would trail the advance. Instead, it often ran ahead of it. Lines were restored to areas the Allies had not yet reached. When ground forces arrived, the logistics network was already waiting. This reversed a basic rule of operational warfare. Supply no longer followed the front. The front followed supply. The impact on tempo was decisive. Allied units could halt, reorganize, and push forward again without pausing for resupply. German units could not. Their logistics stayed brittle, reliant on routes increasingly exposed to Allied air attack. Over time, the imbalance grew. Each successful repair strengthened future operations. More fuel enabled deeper advances. Deeper advances demanded more supply. More supply justified even faster repairs. The system fed itself. German commanders saw the results firsthand. Counterattacks failed not from lack of will, but lack of stamina. Units exhausted ammunition sooner than expected. Fuel shortages forced withdrawals. The Allied front, by contrast, proved resilient. It absorbed losses and continued forward. Railways did not win battles on their own, but they removed limitations. And in modern war, removing limitations can be more powerful than gaining advantages. German engineers noted that Allied rail usage was inefficient by peacetime standards. Loads were lighter, speeds were slower, wear was severe. None of that mattered. Continuity did. German doctrine focused on maximizing efficiency. American doctrine focused on maximizing throughput. Efficiency reduced waste. Throughput reduced delay. On the battlefield, delay was the greater threat. As the campaign continued, German intelligence identified a troubling pattern. Allied rail capacity increased even as bombing intensified. Destruction no longer meant denial. The relationship had reversed. This forced German planners to face an uncomfortable truth. They had prepared to fight an enemy limited by infrastructure. Instead, they confronted an enemy that treated infrastructure as expendable. The logistics effect went beyond material supply. It shaped morale. Allied units expected support, and received it. German units expected disruption and lived with it. Confidence followed reliability. By late summer 1944, German field commanders began to assume Allied supplies would arrive regardless of circumstances. That belief altered their decisions. They withdrew sooner. They conserved resources excessively. They planned defensively instead of opportunistically. The railways created a psychological edge, not through spectacle, but through consistency. German doctrine had not prepared for this. Railways were meant to be fragile. They were meant to collapse under pressure. Instead, they adapted. The logistics effect exposed a deeper reality of the campaign in France. The decisive struggle was not between divisions. It was between systems. One assumed limits, the other engineered around them. As the Allied advance accelerated, German resistance weakened. Not abruptly, but steadily. There was no single moment of collapse, only the steady accumulation of disadvantage. And behind every advantage lay the same quiet cause. Rails repaired overnight, bridges that should not have existed, trains that never stopped moving. The front did not starve. And because it did not starve, it kept advancing. Once the pattern could no longer be ignored, German commanders reacted as doctrine required. They adapted, or at least they tried to. The first response was escalation. More bombs, more sorties, repeated attacks on the same targets. If temporary bridges could be erected quickly, then they would be destroyed again and again. This logic assumed attrition favored the attacker. It did not. German air units became trapped in a loop. They struck known repair sites. They returned days later. The bridges were gone, not destroyed, moved. The Allies did not defend railways the way Germany expected. There were no permanent fortifications, no heavy flak belts protecting bridges. Instead, there was absence. Sites existed briefly, then vanished. German pilots could destroy structures, but not the process that produced them. The next focus was equipment: bulldozers, cranes, rolling stock. German intelligence identified machinery as the true source of speed. But machinery was mobile. Bulldozers dispersed between locations. Cranes traveled with repair teams. Destroying one did not cripple a battalion. It delayed it, briefly. German sabotage units were then deployed. Teams infiltrated behind Allied lines to manually damage rails and bridges. They achieved local success. They failed strategically. Sabotage consumed time. American railway battalions required less. A rail cut that once demanded days of repair was now restored in hours. Sabotage became a nuisance, not a solution. German planners also attempted prioritization. They focused on major junctions and river crossings. If minor lines could be ignored, perhaps destroying key nodes would still paralyze the network. This assumption collapsed as well. The Allies anticipated it. They bypassed junctions. They constructed temporary crossings upstream and downstream. Traffic flowed around destruction. The rail system no longer depended on single points of failure. It offered alternatives. German doctrine held that complexity created weakness. In the Allied system, complexity created resilience. Attempts were made to imitate Allied methods. German engineers experimented with faster repairs. Standards were reduced. Temporary measures were discussed. But Germany faced limits the Allies did not. Equipment was scarce. Fuel shortages restricted heavy machinery. Air superiority was lost. German engineers worked under constant threat without the protection of Axis Allied units enjoyed. Speed could not be produced by doctrine alone. There was also a cultural barrier. German engineering traditions prized correctness. Shortcuts implied failure. Temporary solutions felt irresponsible, dangerous. American units accepted danger as the price of momentum. German units avoided danger and paid with delay. The difference was not awareness. German planners understood what was happening. The difference was capacity. The Allies had planned for this problem years earlier. Germany had not. By the time revised German directives emphasized speed over perfection, the moment had passed. The Allied rail system was already established. It adapted faster than German countermeasures could be devised, let alone applied. German air commanders acknowledged the futility. Reports described rail repair as elastic. Damage inflicted one day reappeared the next. There was no fixed target set. This produced strategic paralysis. If bombing could not deny logistics, what could? Germany had no answer. The failure to counter Allied rail repair was not the result of a single error. It was the result of structural imbalance. One side built doctrine around rapid adaptation. The other built doctrine around control. Control failed once control was no longer possible. By autumn 1944, German planners no longer expected rail destruction to halt Allied operations. They hoped only to slow them. Even that hope proved excessive. The response phase ended not in dramatic collapse, but in resignation. Railways would be destroyed. Railways would be repaired. The cycle would continue, and Germany could not stop it. This realization marked a shift. The railways were no longer a contest. Germany believed it could win. They became another front already lost. What remained was to understand the significance of that loss, not in steel or timetables, but in doctrine. By late 1944, German planners were no longer debating what was happening. They were debating why. France's railways were functioning under conditions that should have made them unusable. Bombing had failed to impose decisive disruption. Repair speed consistently exceeded destruction. The explanation was not technical. It was doctrinal. German and American engineers were solving different problems. German doctrine treated infrastructure as something to be restored. American doctrine treated infrastructure as something to be used. That distinction shaped every decision. In German thinking, a railway was a system governed by standards. Track geometry mattered. Load limits mattered. Durability mattered. A line that failed to meet these requirements was unsafe and therefore unusable. American railway battalions rejected this binary view. A railway was not simply working or destroyed. It existed along a spectrum. If a line could carry a single train, it mattered. If it could carry 10, it mattered more. The objective was not abstract safety. It was immediate movement. German doctrine focused on preventing failure. Design standards existed to avoid derailments, collapses, and catastrophic accidents. American doctrine assumed failures would happen. They planned for them. This difference reshaped risk calculation. German engineers delayed repairs to minimize failure. American engineers accepted failure to minimize delay. In a war driven by tempo, delay was the greater danger. The doctrinal divide went beyond engineering. It was embedded in command culture. German officers expected precision and strict adherence to procedure. American commanders delegated authority aggressively. Railway battalion leaders were empowered to decide on the spot, without waiting for approval. Speed was built into the system. German repairs required coordination across multiple offices. Surveys needed authorization. Materials had to be allocated. Plans had to be validated. American battalions arrived with materials already assigned and authority already granted. They did not ask whether a repair met standards. They asked whether it worked. The gap also reflected industrial culture. German industry prized craftsmanship and optimization. American industry prized scale and redundancy. A German solution aimed to be correct. An American solution aimed to be sufficient and repeatable. When German engineers evaluated American repairs, they judged them by German criteria. They expected collapse. They waited for physics to punish shortcuts. But the Americans were not defying physics. They were using its margins. Speed limits were lowered. Loads were managed. Failures were anticipated and contained. A bridge did not need permanence to be decisive. It needed to exist at the right moment. German doctrine struggled to adapt because adaptation threatened identity. Lowering standards felt like surrender. Temporary fixes felt irresponsible. In peacetime engineering, they would have been. In total war, they were necessary. The gap widened as the campaign continued. Each successful American repair reinforced confidence. Each ineffective German countermeasure eroded faith in old assumptions. By the time German command recognized the doctrinal mismatch, the outcome was already set. Doctrine cannot be rewritten overnight. Training cannot be compressed into weeks. Industrial systems cannot be reinvented during collapse. France's railways became a test case, not of engineering skill, but of philosophy under pressure. Germany believed infrastructure imposed limits on operations. The Allies believed operations defined what infrastructure needed to be. One side accepted constraints, the other engineered around them. This shift did not announce itself dramatically. There were no headlines declaring doctrinal failure, only patterns, continuous movement, unbroken supply, an advance that never truly stalled. In hindsight, the difference was clear. The Allies did not defeat German rail doctrine by destroying it. They made it irrelevant. Railways were no longer fixed assets to defend or demolish. They became flexible tools, assembled, dismantled, and reassembled as needed. German doctrine had no response to that reality. By autumn 1944, the outcome in France was no longer in doubt. The front kept moving east, and the railways followed. Or more accurately, they arrived first. The doctrine gap had done its work, not through dramatic collapse, but through quiet inevitability. No German position in France collapsed because a single railway bridge fell. No Allied breakthrough occurred because one rail line reopened. There was no decisive moment marked by drama. It came quietly, over weeks, through consistency. The campaign in France was not decided by one maneuver. It was decided by whether momentum could be maintained. And momentum depends on logistics. German commanders expected friction to build. They expected pauses. They expected exhaustion. They expected the Allied advance to slow and eventually stall. Those expectations were reasonable. They were also incorrect. What German planners did not understand was that logistics had become anticipatory. Allied supply systems no longer followed the front. They shaped it. Rail lines were restored not to support yesterday's positions, but tomorrow's objectives. That reversal changed everything. Operations could be planned boldly because supply was assumed, not hoped for. Commanders could accept risk because resupply was dependable. German commanders could not. Their logistics had become reactive, restricted by air power and shrinking resources. This imbalance produced quiet but decisive effects. Allied units advanced with confidence. German units conserved resources, hesitated, and withdrew sooner than doctrine advised, not because of fear, but because of uncertainty. The railways created certainty, not through sheer capacity, but through reliability. A supply system that delivers consistently reshapes decisions. German intelligence observed Allied rail usage that seemed inefficient. Trains moved under reduced speed limits. Loads were lighter than design capacity. Temporary bridges were visibly fragile. Technically, it appeared wasteful. Strategically, it was unstoppable. Efficiency conserves resources. Reliability determines outcomes. In France, reliability prevailed. The invisible decision occurred when German commanders quietly accepted that Allied supplies would arrive regardless of German action. That acceptance altered behavior. Counterattacks were tentative. Reserves were withheld too long. Opportunities went unused. Not because they were unseen, but because they could not be supported. Allied commanders assumed continuity. If an advance paused, it resumed. If a line was broken, another appeared. That expectation reinforced itself. The railways removed doubt, and doubt is warfare's hidden cost. By late 1944, the front in France no longer resembled a contest between equal systems. One side operated under constraints that tightened daily. The other actively engineered constraints away. German engineers believed destroying railways would force the Allies to fight on unfavorable terms. Instead, it forced Allied logistics to adapt faster. Pressure meant to paralyze the system refined it. This was the invisible decision. Not a lost battle, not a seized position, but a campaign decided by which system could absorb stress without failing. Railways never dominated headlines. They appeared only in reports and supply charts. But they determined which army could keep moving and which could not. Germany planned for a war where infrastructure imposed limits. They encountered a war where limits were temporary. By the time Paris was liberated and the Allied advance accelerated eastward, the outcome was already decided. Not by tanks, not by generals, but by steel assembled at night, destroyed by day, and rebuilt again before dawn. The railways did not win the campaign. They ensured it could not be lost. German engineers did not abandon their convictions the moment the campaign in France was lost. Beliefs almost never collapse all at once. They wear away. In the months following the Allied breakout, German rail specialists continued to submit reports. They recorded damage, they listed losses, they analyzed breakdowns. But the tone shifted. Early reports had carried confidence. Later ones became cautious. By late 1944, they were clinical. Assumptions were no longer defended. They were dissected. Captured files and post-war interrogations reveal a quiet change. German engineers stopped debating whether the railways could have been denied. They began debating how long denial had ever been possible. The answers were unsettling. Several officers admitted that their calculations had been accurate for German methods. Repair timelines had been based on standards they themselves would have enforced. They had never accounted for an enemy willing to discard those standards entirely. A recurring theme appeared in post-war reflections. The Americans had not repaired railways. They had improvised them. The phrase was not intended as praise. It was criticism. Yet the implication was unavoidable. Improvisation had been enough. German engineers acknowledged that their doctrine treated infrastructure as binary, either intact or destroyed. They had not planned for infrastructure that existed in a constant state of compromise, unstable, temporary, yet functional. That middle condition had not existed in their models. Some officers cited shortages, fuel constraints, loss of equipment, loss of air superiority. All were real. None explained the core failure. Even under ideal conditions, German doctrine would have struggled to replicate Allied results. The obstacle was not material, it was conceptual. American railway battalions were authorized to decide on the spot. German engineers were not. Authority in the German system moved upward. Decisions required approval. In stable conditions, this protected quality. In fluid conditions, it guaranteed delay. Post-war studies returned to this contrast repeatedly. Speed had been treated as secondary. Reliability had been defined as durability, not continuity. The war punished those definitions. German officers also recognized an industrial mismatch. American industry had produced standardized solutions in advance, prefabricated bridge sections, modular equipment, interchangeable parts. Germany, limited by resources and doctrine, relied on bespoke solutions. Each repair was unique. The Allies assumed destruction was inevitable and prepared for it. The most revealing admissions came last. Some German engineers conceded that bombing railways might never have been decisive against an opponent willing to accept imperfection. Destruction without denial, they concluded, was insufficient. That realization arrived too late to change anything. In the post-war period, German rail doctrine shifted quietly. Standards remained rigorous, but contingency planning widened. Temporary solutions, once rejected, were reconsidered. The lessons of France could not be ignored. For the Allies, the experience confirmed an approach that would shape post-war logistics. Flexibility over formality, redundancy over optimization, speed over perfection. These ideas extended far beyond railways. The aftermath carried one final irony. German engineers had been correct in one respect. France's railways had not been rebuilt properly during the campaign. Many temporary structures were replaced after the war. Tracks were realigned. Bridges rebuilt to permanent standards. By peacetime measures, American solutions had been inadequate. By wartime measures, they had been decisive. The difference lay in the question being asked. German engineers asked, "Is this the correct way to build a railway?" American engineers asked, "Is this enough to win?" In France in 1944, that question settled the campaign. Quietly, invisibly, irrevocably. When the campaign in France ended, there was no ceremony celebrating logistics. No medals were pinned to bridges. No parades followed repaired rail lines. The trains simply continued to run. History tends to record outcomes through battles, but outcomes are seldom decided there. They are decided in the spaces in between, in schedules, tonnage figures, repair logs, and tolerances. France in 1944 was one of those spaces. German planners believed railways imposed limits. They believed destruction created certainty. Destroy the lines, and the advance would stall. What they learned, too late, was that limits are not absolute. They are negotiated. The Allies did not reject engineering laws. They redefined their importance. A bridge did not need longevity. A rail line did not need elegance. A system did not need completeness. It needed to work long enough to matter. That reframing altered everything. Infrastructure ceased to be static. It became flexible. Something built, dismantled, and rebuilt as conditions required. France's railways became transient, present when needed, invisible when attacked. German doctrine could not keep pace with that fluidity. It was designed to control systems, not pursue them. Once control slipped, denial collapsed. In the end, the campaign was not lost because German engineers lacked skill. They did not. It was lost because their assumptions were exact, and exactness became a weakness. American railway battalions did not surpass German engineers in craftsmanship. They surpassed them in tempo. They accepted risk where German doctrine sought to remove it. They exchanged permanence for momentum, and momentum decided the outcome. The railways never commanded headlines. They never filled dramatic footage, but they ensured Allied armies never paused long enough for German defenses to recover. They removed waiting. And waiting is where wars are often lost. The final reckoning was not an admission, it was an absence. The absence of the logistical crisis Germany had expected, the absence of the pause that never arrived, the absence of the collapse destruction was meant to cause. Long after combat shifted eastward, the lessons endured. Modern military logistics would be shaped by France, by the idea that systems must function while damaged, by the realization that denial requires more than destruction. It requires outrunning repair. France's railways taught a quiet lesson. In modern war, victory often goes to the side that treats infrastructure as expendable and capability as continuous. Not flawless, not permanent, continuous. This is why the campaign did not hinge on one bridge or one bombing mission or one repair crew. It hinged on whether a system could absorb pressure without failing. One could not. The trains kept running, and because they did, the front kept moving. That is how the campaign was decided, not in a single moment, but in motion.